Hello, welcome. Hi, Kevin, who just came in. I'm just at the very end of Unit 6 now, and by very end, I mean I'm in Example 4. There are more examples in the notes, but if I cover them, I'll be more likely to cover them in the next class, which is going to be a review class. But right now, I just want to get to the essence of the questions, and then we'll do Unit 7, and we'll be actually done all the content for the course, okay? And the rest will just be some review. So without further ado, let's get started. So to sketch a graph, you need three key points. And what I said yesterday was intercepts, usually x-intercepts, critical points, and inflection points. So that's the steps I'm going to take. I'm going to write down what my x-intercepts are. And remember, that's setting y equal to 0 and solving for that. So we can set this directly to 0 because it already is the y. I'll just take x outside of x minus of 6 minus x, and we set both of those equal to 0, and you'll see very quickly that x equals 0 and x equals positive 6. If you set both of those to 0, that's what you get. And what I did yesterday was I was making a table of values as I went, and because I wasn't sketching, I was just comparing it to Desmos, the table of values didn't actually get me anywhere most of the time. But today it will. We're going to be able to actually write these things down. So the x values are 0 and 6, and by definition, that's where y is 0. So that's y of 0 for both of these. So I can already make a sketch. I can put these values on this graph, 0 and 6, and I already have my two x-intercepts in blue so that the colors are matching. Hey, Hauser, nice to see you. The next step is going to be finding our critical points. The critical points, once we check them and test them, they tell us if we have a maximum or a minimum, which you should remember from yesterday. So we're going to be checking the slope. So the first thing we do is get the first derivative. That's 6 minus 2x. We need to set that to 0. Good afternoon, Hamza. Nice to see you. Set it to 0, factor out the common factors, which in this case gives us 2 outside of 3 minus x. And this is a very easy x to solve for. In this case, let me color code some of this stuff so that when you look back on it, it's more clear for some of you anyway. Some of you hate it when I do that. But in this case, x equals 3. So to be clear, x equals 3, what that means is that's a either maximum or a minimum. We don't know if it's a maximum or a minimum yet because we haven't tested it. And to do the test, we do what's called the first derivative test. So let me draw it on the number line. I'm going to put the number 3 there. And I'm going to do what's called the first derivative test, which is why I put f prime there. And I check the sign on either side. I need to see if the slope is positive or negative on the left and the right. So take this, right? Take that, and take any number bigger than 3. So, okay, 2 and 4. Mohammed says 2 and 4. Let's try the number 4. So the number 4 here is what I would test. It would be 2 outside of 3 minus 4. Right away, I say that gives a negative. So that whole region is negative. The whole region to the right of 3 is negative. You don't need the workings for that. Again, put any number bigger than 3 into this and see what the sign is, and that's your slope. So the slope's going to be negative on that side. So what that means for us is when we look at this 3, we have this 3 here. On the right side of it, we're going to have a curve that looks like it's like this, and on the left side is probably going to be positive. So let's check it. Let me check my 2. So on the side, I'll check 3 minus 2. Again, any number less than 3. This will also give a positive. So we have positive. Slope is positive. What that means is that we must have positive slope going to negative slope, which means we have a maximum. That means that x equals 3 is a maximum. It means that x3 and whatever number that is. So once again, if you're not sure from yesterday, we take these x values, put it in here, and then spit out the answer, and that'll be where it is on the curve. What do we have? We have 3 times 6 minus 3, which is 9. It's okay, Mohammed. It's just good that you're here. You have 9. So we can already write 3 and 9 on the curve. So it's very easy to write this curve. I can pretty much guess already that it's going to be like that. I mean, it's probably going to be this. This is a simple function, so it's easy to tell. But before I do anything else, I'm going to circle my x-intercepts. I'm going to, box them, box my critical points. What's my next and final step? What's it called when I find the last thing? F double prime, that's right, Mohammed. What's it called? What kind of points are they? What am I solving for? It's where the function would twist or the concavity or inflection, yeah. So we're looking for inflection points. So that's when y double prime equals to 0. So I'll solve for the second derivative. The second derivative in this case, just look over here. The first derivative was 6 minus 2x, so the second derivative is negative 2. It turns out that, sorry, negative 2, not negative 2x. It turns out that there is no inflection point. But the whole graph, the whole curve is concave. And if you remember from yesterday, what does a negative mean? When we have a negative for the second derivative, it means we have concave down, which means like this. So Ibrahim, you asked me, why is there no inflection point? And there's no inflection point because we would need to solve for x equals something. Okay, that's the whole point. Before we were solving for x's. If you look at this equation, look, there is no x to solve for. So there's no inflection point. So what this looks like, if this curve is concave down, well, we have positive slope to the left of this, and we have negative slope to the right of this. That's it. Okay, no matter where, if we put our f double prime on this number line, it's concave down all the way on both sides. So long story short, we have this graph that looks like this. Okay, this is just a very basic sketch. The rest of the unit goes into more complicated sketches. Happily, you don't need to do them in this course because we kind of ran out of time and they take a little bit more time than we need. And because the final exam is nice, because the final exam is just multiple choice, we're not going to get you to sketch it anyway. So the ones that you'll need to know, and I'm going to give you just a little sneak peek, we'll do it tomorrow, is this extension worksheet that I asked you to look at. And these are the questions that we're going to answer, okay? So I'll answer all of these tomorrow, and if you can do those, it looks like a lot, it's actually not. I'm giving you all the little bits. I'm going to break the curve into tiny little pieces so you can figure it all out. If you can do that worksheet, which I've already given the answers to, if you wanted to look at it yourself, if you can do that worksheet, you can absolutely get 100% on those two questions, on the Unit 6 and the Unit 7 question, okay? We'll do Unit 7 now. So before I move on to Unit 7, any little questions left on this question? Because we're actually done now. Okay, sorry, it's been very hot in my house today, and so I'm all dehydrated, so I've got to drink some water. Cool. So, topic 7, matrices. It's the summer, so what do you expect? Okay. I'm just going to bring up my other notes. I've made some quick notes for myself just to make sure that I only cover what's important. So I don't know if you've ever seen matrices before. 9-9, Brooklyn 9-9, yeah. You know it. 9-9. So what's a matrix? Just shut up, Hansa. I'm trying to talk. What's a matrix? It's something that looks like this. What I mean is it's just a bunch of numbers, but they're arranged in a special way. And the way that they're arranged is in rows and columns. So in this case, we have 2 rows. And in this case, we would have 3 columns. Okay? 2 rows, 3 columns. what's that called? What that is called is a 2 by 3 matrix. That's the name. So if you did it in Math 1, it should be pretty straightforward. I can't remember what you covered in Math 1 actually, but I don't think you'll have much problem with this. So just to be crystal clear, because a lot of students get the rows and yeah, just stop. The rows and the columns, it's always rows first, columns second. And for some reason, it took me until probably my second year or third year university to stop mixing them up. I don't know why, but rows and columns, X then Y, or horizontal then vertical. I don't know why, it just didn't stick. And if I say something that, if I say dimensions, what I actually mean is I'm saying the size. It's the way that we say what the size of matrix is in like matrix words. Unfortunately, not the 1990s super film starring Keanu Reeves, who you'll see in 2021 starring in The Matrix 4. Unfortunately, not as exciting. So what we're going to cover today is basic operations, scalar multiplication, determinants. We're also going to talk about basic properties, and it really is basic. We're going to do multiplication of matrices, inverse of a matrix. We're going to solve some equations, and we're actually not really going to do those applied problems. That's about it. I'm just looking at the chat, trying not to be distracted. I'm never going to get through this today if I keep going back and forth. And finally, in the end, there is an appendix, which means if you want to use your calculator, which you should, the Casio is on page 16 and the TI-84 is on page 18. For anyone who has the TI-84, nothing wrong with it. I just don't have the app on my computer to show you how you would do that, but the notes in the back are clear. I'm going to be doing the Casio stuff today. So if you have a Casio, and it needs to be this gray one, I'm going to show you how to do it. If you don't have it, there are apps on the App Store that you can use. So Calculator ES, or I have one that's called Calc Colorful. Yeah, Casio is the way to go. If you don't have one, honestly, my biggest suggestion would be go buy one before Saturday because this is the best calculator I've ever had. And I've had a lot. And it's just the best. This is something that I would literally use and do literally use all the time. And not just because I'm a giant nerd. It's just the best. It's the best calculator. Okay, let's get started. Very quickly, what is a matrix? It's a rectangular matrix, ordered rectangular array of numbers. A matrix has these, well, let me be more clear. A matrix is in these square brackets. A determinant is in these vertical brackets, and it's not absolute value. So some students think that it's absolute value. It's not, it's its own operations that are related to matrices only. Okay, so that would be the first thing that I would mention. As for what the numbers inside are called, we call them elements. So we have many elements to a matrix. In this case, we have 1, 2, 3, 4 elements. They're just the numbers inside a matrix. You can't just call them numbers because they have a specific position. It says the dimensions are defined in terms of rows and columns, which I talked about before. 4 rows, 3 columns, read as 4 by 3. Square matrices are just that, they're square. They might be 3 by 3, they might be 4 by 4, they might be 2 by 2, they might be 5 by 5, who knows? But their size, that's not a square, their size is equal rows as columns, okay? That won't come up too much in this course. And there are some other special types of matrices. I'm just getting you through the basics here. A zero matrix, also called a null matrix, all elements are 0. An identity matrix means we have 1s on the diagonal. The 0s are the rest, okay? So yeah, the notes are complicated. I'm going to try and make it clear to you. I'm just getting you the basics. Most of this is not going to come up in any crazy way, okay? All I'm trying to say is the basics. All you need to know at this point, what's a matrix? It's a bunch of numbers in a box, and the boxes have square sides. The determinant is a special thing, just like multiply and divide. It just, if you need to get the determinant, you have these vertical sides. The dimensions is 4 by 3, the size of a matrix. A square matrix is if it literally has the same number of rows as columns. It's just what we call it. And finally, a null matrix, zero matrix, is just that. It's a matrix with a bunch of zeros in it. And an identity matrix is another way of like having a 1. Like if you had 1 times 1, it's still 1. If you have 1 times 2, it's still 2. It's just a matrix version of that. And you'll notice that the 1s are on the diagonal and you just have zeros in the rest. So if it comes up, okay? All I'll say next on this page, the zero matrix has an O, identity matrix has an I. And if it comes up, that's your basics, okay? Don't worry, it's all gonna be clear. You're gonna be fine. You're gonna get full marks on this part on the final if you just pay attention. I'm here to carry you through to the finish line, okay? Just relax. Don't worry, Ibrahim. It's gonna be fine. It's gonna be fine. So scalar multiplication. Let's get started on matrices. It says if A is this, find 5 times A. Well, do you know what you have to do? You multiply 5 by everything. So 5A is 5 times every element. What's 5 times 3? 15. What's 5 times 9? 45. What's 5 times 4? 20. What's 5 times 2, or negative 2? Negative 10. Okay? That's scalar multiplication. If it says multiply by a 5, you multiply by a 5. Okay? Halas. We're finished. This one here, you know, the first one, 3A. I'll do it just because it's so fast. 3A. Just multiply every element by 3. Done. In B, if you want 1 over 4B, you just divide every element by 4. Well, 6 divided by 4 is the same as 3 over 2. 3 over 2 and negative 1 and 1 over 4 and 3 over 4. Okay, Mohammed, take your time. And then 9 times C, I'll let that be yours. You know, it's not exactly a difficult question. Take every element and multiply it by 9. Okay? I want to get to the more interesting stuff. Determinants. Determinants on the page looks very complicated. Determinants, the strategy we use is super easy. If you have a 2 by 2 matrix, this is what you do. Take the diagonals, multiply them and subtract them. Okay? You'll notice that this is 4 times 3. This is your 5 and your negative 1, and you just subtract them. That's 12 minus negative 5, so 12 plus 5, 17. Okay? So that's all we need to do for the determinant. I'll give you another example before I show you how to do it on a calculator. So let's give another example. What if we wanted the determinant of the matrix 1, 2, negative 3, and 4? Yep, very easy. See, I told you I'm going to help you out here. You're going to be fine. Determinant, take 1 times 4. 1 times 4, and you subtract. I like to think of it as work from the top. So 1 times 4 and 2 times negative 3. You can use brackets if you want. Some students prefer that, so I'll put them in. 1 times 4, 2 times negative 3. What does that give me? Well, it gives me 4 plus 6, which is 10. So I'm seeing you guys say it in the chat. Easy peasy lemon squeezy. Not too bad. Now I'm going to show you how to put matrices into your calculator if you have a Casio. If you have a TI-84, it's a different method. In fact, it's a little bit easier, but I don't have the calculator to show you here. So you'll just look at page 18, okay? In fact, if you only have the TI-84, you can go to page 18 while I'm talking and try to figure it out if you want. So I'm just going to show you the basics on the Casio. So let's just say I wanted the determinant. So I'm in my computation mode, my regular numbers mode, yeah? And if you want to start working with matrices, this is what you do. Step 1, mode 6. So mode is up top, hit mode, Matrix is mode 6, so you hit 6. And what it's going to ask is which matrix do you want to start saving? So I'm just going to set up a first matrix, matrix A. It's always called A, whatever. And how big is that matrix? This is a 2 by 2, so I'm going to set 2 by 2 is 5, so hit 5. Set up your matrix. 1, 2, -3, and 4. And you have to hit enter after every one. If you don't hit enter on the last step, it won't save it. So look at your matrix, make sure it says 1, 2, -3, and 4. Your matrix is okay. And you should have the last number on the bottom here because it'll tell you it's been saved. And this next step is the most important step of the whole thing. When you finish saving your matrix, hit AC. Do not hit anything else. AC is the only button that will save it, okay? When you hit AC, it'll just clear it. You'll see up here it says MAT, it's matrix mode still. Don't hit on, don't turn it off. If you do anything but AC, it will clear the memory and delete your matrix. So make sure you hit AC. The next thing you want to do is get the determinant. We never go back to mode 6. Okay, mode 6 is how we found the matrix. To go forward, we hit Shift 4. And it makes sense because look, Shift is your Shift key. And then look, matrix is above the number 4. So matrix mode or matrix operations. So Shift 4. And then it says, what do you want to do? Well, what you want to do is get the determinant, which is actually already in the calculator as number 7. So put number 7 there. Determinant, it opens a bracket and says, what do you want to put in? You got to go to Shift 4 again. Never mode 6 again. Shift 4. And you've saved it as matrix A, so 3. Okay, so long story short, mode 6 does all your saving of the matrix, the first matrix, and then Shift 4 is all your operations. And if I click this now, what am I supposed to get? Probably a 10. Enter. It's 10. So the calculator did all the workings in the background and got me this answer. The problem is, if you have a bigger matrix, it's much faster to do it on calculator. For a 2 by 2, it's actually faster to do it by hand, much faster. So this is how we do it. I'll show you how to do more of those later, in a couple minutes actually. So find the determinant of each matrix. I'll do the first one by hand, and then I'll do B on the calculator. And if you want to do B right now on your own on the calculator, that's fine too. As a reminder, the Casio is on page 16. TI-84 is on page 18. So Abdulkader, you said, do you have to do it by calculator? There are other ways to get the answers for 3 by 3s by hand, but we don't cover them in this course. So the 2 by 2s, definitely you can do by hand. There's no need to do it on a calculator. 3 by 3, 4 by 4, 5 by 5, you would want to do those on a calculator. Okay, so here the determinant is 9 times 1 minus 4 times -2. And that gives us 9 plus 8, which is indeed 17. That is much faster than a calculator. I don't know why anyone would choose to use a calculator on that one, okay? So that's the first one. The second one, B, I am not going to do by hand. What you would need to do is you'd actually need to consider these diagonals. You'd have to do all sorts of stuff, and you actually have to go back and multiply by the other diagonals as well. So it ends up being like a whole mess. So you have to do a whole bunch of operations. It's way harder. We don't cover it in this course. We just do the calculator. So I'm going to show you how to do the 3 by 3 in the calculator. Because I'm starting again, I'm going to actually clear everything out. I'm going to go back to mode 6. I said never touch mode 6, but what I mean is don't touch mode 6 if you're doing the same problem. If you're starting new matrices, mode 6 is okay. If you're starting a new problem, mode 6, I want to set up a new matrix. It says M, but really call it what you want. So I'll call it A again. And it's a 3 by 3, which is number 1. And it should say, okay, give me the 3 by 3 numbers. So you have 3, -5, and 8, 2, 9, and 0. Then I have 4, -2, and 3. Yeah, your answer is right. And then you want to hit AC to save it. When you save it, it doesn't do anything because you have to tell it what to do with the matrix. And that's under Shift 4. So Shift 4, determinant 7. So Shift 4, 7, and then Shift 4 again to bring up your matrix. Do not hit mode 6 again. It will clear your work. Okay? It'll just break what you want to do. Equals negative 209. I'm not going to write anything more. The marks are given based on being able to calculate it using the calculator. And honestly, most people in their right minds at a high level math, when they're doing matrix multiplication, they have a computer do it for them anyways. So it's just a matter of knowing how to give the computer the steps. Okay, I'm not going to do the rest. Can I just get a feeling for how that is? Because we're actually going to move on from determinants now. Sorry, we're going to do D, which is a different type of question. All good? I need another drink of water. Okay, well, C is clearly a challenge. I wouldn't ask you to do this. In fact, the Casio can't even do it on the Casio. You can't do it on the Casio. You can only do it on the TI-84. Zara, yeah. I have crappy internet, and just when I needed to see how you did that on a calculator, your voice went robot and it stopped. Yeah, okay. I'll do it again. I won't be doing the determinant on the calculator again, but I'll be doing similar ones on the calculator again, so you should be okay. Yeah, and Zara, if you don't have the silver one, you can't do matrices on it. So just as a side note, if I was to give you one on the final, I'm only going to go up to 2 by 2. All right, because at this point, it's not fair to ask you to do anything that's bigger. All right, so anything on the final, you don't actually need to calculate it with the calculator. You can do it by hand. Okay. So even though I'm going to be doing calculator stuff today, most of it that you'll need to know is just the by hand stuff. Okay. If you want the gray one, you'd need to look up 991ES. And once again, you can find it on Android or the App Store. All right. You can find an app version for now. Okay, let's keep going. D. This one's a little different. It's kind of an extension question, but I wouldn't call it difficult. Cracked calculator on a laptop. Yeah. So what are you using this one? Yeah. Cheats. If you contact me, I can send it to you. You'll know it's the right one because you say the cracked version for HTKC. Easy to find. Anyway, let's do this. It says if the determinant, and we know that this is determinant because of these bars, if the determinant of this matrix is 12. So Zara, I just told you, but I'll repeat it. For the final, I'm not going to give you any questions that you need the calculator for. You'll be able to do it just as easily by hand. Yeah. It's not going to be unfair. If you get to the final, the questions I'm giving will be made in such a way that you do not need the calculator. You'll be equally fine doing it without. And yes, tomorrow is our last class. Let's do this question. What are the values of t? We need to solve for t. So first things first, we'll get the determinant, and then we'll compare it to 12. Okay, and let's see what happens. So we have, we know that 7 times 4 minus 2t times t equals 12. You're going to be even more bored when you finish classes. Or do you mean you'll be more bored in that class? Okay, yes, Mohammed, we're going to divide. We'll have 28 minus 2t squared equals 12. And then we're just going to solve for t. We're going to eventually divide. Not quite yet, but we will. We'll bring the 28 to the other side. That'll give us negative 2t squared equals negative 16. I'm just solving it like normal. The first step was the determinant step. The rest is regular stuff. So divide by -2 on both sides. That means t squared equals 8. And then we need to get the square root of both sides. That cancels the square root and the square. And we get 2√2. Or in other words, you could call it 2.8 or something similar, but it's 2√2 really. Not quite 4. I think you divided by 2 instead. I got the square root. Common mistake. So yeah, 2√2 is 2.828, blah, 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 and so on. So this is how we do this question. Pretty easy. The first step, just so we're clear, is do the actual determinant. And then the second step is solve for 2. Easy peasy. I think it's pretty easy. In fact, it's kind of the reason why we keep this unit to the end. The matrices are totally unrelated to everything else you've done. So even if you're terrible at the rest of the course, you still have a chance to do well on this stuff. And it can easily be done in one class. All right, so we kind of give you a little treat at the end. It's really not that bad. So let's keep going. What's the next topic? They have these fancy names: commutative, associative, distributive, null. But really all it's saying is that matrices essentially follow the same rules as regular numbers in a lot of ways. There are special cases, but just let me show you what I mean. 3b. Okay, how do we get 3b? We take the matrix B. So 3b, we want to multiply all of this by 3. So let's take every single element, multiply it by 3. So 9, 6, 12, -15, 27, -6. Of course, you can do this on your calculator if you want. I'm doing it in my head. 8 times 3 is 24, 0, and 9. Okay? So that's 3b. Literally just take your 3, multiply it by everything in the matrix. Same as if you had 3 times anything. 2a, same story. So multiply everything in matrix A by 2. It should still be a 3 by 3. It's just multiplied by 2. So that one's really easy. All right. So the only thing that should slow you down here is if you're a slow writer, which believe it or not, in classes when I was in university, I was a really slow writer because I wanted to take time to think about it and write it. And my instructors were super fast. I had one guy that he wrote so fast that he couldn't speak fast enough. He would write and he would try to speak along with it and he couldn't. So he would write it all out and then he would just stop mid-sentence and say, and you can see the rest. Let's move on. I was just like, what? What kind of robot are you? Who can do that? Anyway, you don't need to hear my stories. So long story short, I took matrix B, multiplied it by 3. I took matrix A, multiplied it by 2. And now what I need to do is take 2A and subtract 3B. All this means is we take all the elements in 2A and subtract 3B. Or let me be more clear. Every element, it's almost like we put it on top of each other. 6 will be related to this one, okay? It's the same position in the matrix, row 1, column 1. We subtract. So let's show you what it looks like. It's still a 3 by 3. Let me be very clear here. Our matrix really, it's like got these invisible lines. It's still going to have 9 elements. But the first element here, it's 2A minus 3B. So it's going to be 6 minus 9. Are we clear on that? Because every other single one here is the exact same. Okay? We take the position from 2A there, subtract the same position from 3B, and we get our answer. That will be a 3. I'm going to go one step further. When I simplify this later, it's going to be a -3. Okay? All clear, I hope. So once again, I'll show you a couple more. This one minus this one. So it's 4 minus -15. And I'll show one more. I won't do every single one. But 4 minus 24. So 4 minus 24. 14 minus 24, sorry. All right, and following the same pattern, I'll write out all the rest. you can do the same. I'm only showing every single step the first time. I won't always show every step. And I'll solve these now. Okay, so it's a little bit messy. They should have given me a little more space, but this is the big idea. If you're subtracting matrices, just match up the position in the matrix. Row 1 with column 1, they match up. The second row with the second row, first row with the first column, whatever. The positions need to match. All good? 4 minus 15 is negative 11. It's 4 minus minus 15. 4 minus minus 15. Is that okay, Ibrahim? Remember that it's all minus. So there's a little minus in here. Okay, that's it. That's all I need to show you for the addition and the multiplication. When you multiply matrices together, we have a different system, but when you're just subtracting them, it's really simple. So when we multiply a number by a matrix like this, it's called scalar. So this whole section is called scalar multiplication. It's like constant multiplication. And the other one is, of course, called subtraction. For here, it says evaluate the determinant of each. I don't need to show that. We've already done that. You can do it for homework if you're interested. You just need to get the determinant of A and you need to get the determinant of B. I'm not going to do that again. I'll do it later if I have to. Okay? You would use a calculator. So it's a 3 by 3. 3 I will do because it's a little more interesting. Let's see, I'll just do the first one. The second one you can do yourself. So what we have here, we have a matrix equal to another matrix. So we kind of need to match up common terms. So if you look at this, look, you can see that 6 is equal to 6. Well, that's not helpful. But what is helpful is like, okay, 4 is equal to 4, of course. 4 is equal to 4. But look at this. Ooh, negative 10 is equal to 2t. That we can use. So if these matrices are equal, we can immediately jump to that answer. We know that negative t equals 2t. You can easily solve for t. I'm not sure how you get negative 5 and 3. Where did 3 come from? Divide both sides by 2. You might have made this more complicated than it needed to be. You're just matching, okay? We know that all the elements are matching. Just look, right? 6 equals negative 6. 6 and 6, of course, that's the same. 4 and 4. 4 and 4, but this is the interesting one. Negative 10 and 2t. So just, no need to factor. It's negative 10 and 2t. There is no factoring, really. You wouldn't need to. You're solving for t, not factoring. You're still thinking curve sketching, I think. So calm down. We've gone to the more easy stuff again. I said I wasn't going to do B. How about you try B? Take 2 or 3 minutes. It probably won't take that long. And do B. Notice that this is not the same as this. This is direct. This question is actually, these are determinants. And I'll give you a hint. You need to get the determinant of the first one, the determinant of the second one, make them equal, and then solve for t. See what you get. I'll give you 2 minutes to see how far you can get with that. It's one single answer, t equals number. Give it a think that's enough time. 11 is not the answer that I got, but that doesn't mean that you're not right. It might just mean that I got it wrong. So let's see. Remember, determinants are minus. You do the diagonal minus the other diagonal. So negative 2 times 1 minus 5 times 3, or 3 times 5. Then we have 3 times 9 minus 4 times t. So let's simplify that. The left side here, negative 2 minus 15 is negative 17. On the right side, we have 27 minus 4t. So I'm looking at my old notes. Yeah, I multiplied 3 by 9. I got 18. I messed that up. That's my mistake. So we solve this. Bring the 17 over to the other side. And negative 44, yeah, we're going to get 11. So I totally messed it up with my other class. But to be honest, I think they're pretty much zombies anyways. So I don't know if it mattered. I don't think anyone was even listening to me. So it didn't matter. Big surprise, no one listening to you, sir. All right. It's 11. Good job. If you got the negative, you just made a little issue with the signs. But other than that, I think it's all good. Thanks, Hamza. Warm in my heart. Let's go move on. We've got the determinant stuff done. We've got some addition done. We've got some multiplications done. Let's do what I think is the hardest topic in the unit, but actually still a pretty easy topic, and it's matrix multiplication. And this is another one where it might just have to click, but I'll try to make it as clear as I can. What it says here, and again, it makes it seem really complicated, but I'll try to make it as easy as I can. It says, not all matrices can be multiplied. To multiply matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. So instead of going through all this text, let me just bring you over to a little dream sequence here and give you an example of what that's talking about. So what it means is, if you had a matrix A, let's just say you have matrix A and it's a 3 by 3 matrix. And maybe you have a matrix B, which is a 3 by 2 matrix. What it's trying to say is you can only multiply them if the number of columns in A are equal to the number of rows in B. And if they're equal, then you can multiply. It's just a little check that we do before we start to make sure that we know it's allowed to be multiplied or possible to be multiplied. And we can even know what the final answer, the size of the matrix is going to be. It will give us a 3 by 2 matrix. It's just a neat thing that comes out of this rule, okay? So you can multiply these if those rows and columns and rows are the same. I'll give you an example where they're not the same, or you can make your own, really. Let me move this down a little bit. What if we had a 3 by 3 again, but then we multiply it by 2 by 3? Well, once again, you would look and say, hey, are these equal or not? They're actually not equal, which means we can't multiply. So it doesn't matter. There is no answer. So you just kind of, that's it. You can't even start because you can't multiply them to begin with. All right. Normally the matrices I give you will be able to be multiplied, but I'm going to do that check before I start every time. All right. That's what it's trying to say here. It also says, how do you multiply matrices? And this is the tricky part, and I'll try to make it as clear as I can, but just stick with me for a second because it's not immediately obvious. It says, how do you multiply? It says the element in a specified row and a specified column. So if you have a row in the first matrix, you have a column in the second matrix. In order to do this, you need to multiply all the elements together, but in a really special way. In fact, what we do is we would take A, the first element in the row of the first one, multiply by the first element in the column of the next one. And that gives us this first value, okay? And then you would take the second element in the first row and the second element in the first column, and that would give you the second one. I'll try to make it easier as we go because this is a little bit tricky. So let me give you a small example before we make a bigger example. Because again, I always learn better by seeing an example. So let me see this. I can put any numbers into these matrices. So let's just say I have 1, 2, 3, 4 multiplied by 5, 6, 7, 8. And I want the answer. Of course I want the answer. That's the whole point. So this is a 2 by 2. This is a 2 by 2. Let's first of all see if we're allowed to multiply them to begin with. Am I allowed to multiply them? Can they be multiplied? Will I get an answer? Yes, I will. I see that Ibrahim and Muhammad both said that. These numbers are equal, and I already know what the size of my matrix is going to be. It's going to be a 2 by 2. So whatever I get out of this will be a 2 by 2. The problem is, it can be a little bit tricky to know how to multiply. So this is where you need to pay very, very close attention, okay? This is how you do it. If you want the first row, first column, so if you want this element in the first row and first column, this is what you do. Look at the first row in the first matrix, look at the first column in the second matrix. You take the first element times the first element, 1 times 5, and you add the second element and the second element multiplied together. Okay, this is the big idea. You'll have the first element times the first element in the other row, second element times the second element in the other column. And if you get that, so you say the 1 and 2 will multiply with 5 and 7. Yes, the 1 with the 5 and the 2 with the 7. All right, this is how it works. I wish I had a good way of showing this. This is going to be my bad example here. In the first matrix, you have a column like this, okay? Sorry, a row. You have a row. And in the other matrix, you have a column, okay? They're not the same size. You have a column, all right? Are you good with this? The elements kind of multiply like this on top of each other. So if you could take the first row and the first column, they kind of like, this one goes over here, and then the 1 and the 5, and I'm not sure if that's clear what I'm trying to say. But you have the 1 and the 2. Let's just look at this. You have the 1 and the 2 that you're trying to multiply by that 5 and 7. So imagine taking this and multiplying it over there. It's kind of like they multiply on top of them, right? They come over on top, and they only match and multiply with the ones that they are on top of, if you see what I mean. It's almost like we rotated it sideways and made a 5 and a 7, rotated it, and then we move it over and say, oh, we multiply the 1 with the 5 and the 2 with the 7. You see what I mean? It's kind of a visual thing. We'll do lots of examples, but that's how I think of it. So let's do it again. We're going to do, for the next step, first column with the first row with the second column. So again, we want the first row in the second column. What's it going to be? So 1 with the 6, 1 times 6, added to the 2 and the 8, right? 2 times 8. And I'll do the same thing again for, let's do the first row, or sorry, second row, first column. That'll be 3 times 5 plus 4 times 7. And finally, all I have left is the second row, second column, which is over here. I multiply the second row and the second column. Second row, second column. 3 times 6 plus 4 times 8. And you'll see a pattern in the way that this works. And if you see the pattern, it never changes. Matrix multiplication is always this. It doesn't matter how big it gets, this is the process. So you can even see the pattern in the colors. You know, your 3s and your 4s are the columns, and the 5 and the 7. I'm not going to overcolor this thing because you'll just get confused. But this is the big idea, okay? Let's get the final answer. Normally, I don't show every step. So in this case, let's say I would have done 1 times 5 plus 2 times 7. That would have just given the 19 directly. Okay? And I'll do the next one. 1 times 6 plus 2 times 8, 22. 3 times 5 plus 4 times 7, 43. 3 times 6 plus 4 times 8, 50. So normally when I do this, especially if I'm doing it on my own, I jump straight to this because I'm doing it on my calculator as I go. 1 times 5 plus 2 times 7, 19. But for you, of course, I want to show every step for now. Okay? On a scale of 1 to 10, how easy with a Z is that? 7's okay. Nothing wrong with that. We'll do another example to make sure that it becomes more clear. But for those of you that are getting 10, obviously that's excellent as well. So the last thing I'll say is, look, I already knew it was going to be a 2 by 2 to begin with, because it's like a little check. Let's do another one. Let's do a bigger one. And this one doesn't give us a lot of space, but we'll work with what we're given. So AB. We want to multiply AB. This is a multiplication. Okay, A times B. By the way, you can, before I do this, I'm gonna show how to do this in your calculator because, excuse me, I want you to make, I've never shown you how to save 2 matrices. And the Casio has a really, what I think is a confusing way of setting up the second or third matrix. So I want to make sure I cover that, because otherwise you're going to be confused and you're going to be like me, being all confused, trying to do this once upon a time. So, okay, I've got 2 matrices, A and B. Okay, I need to multiply these. Let's say we're going from the start. Mode 6. This is how I set up my mode 6. Okay, mode 6. My first matrix, I'll call matrix A. It's a 2 by 2, which is number 5. I'm going to put in 1, 2, 3, 4. That's the easy part. Save it with AC. Do not touch mode 6, okay? If you touch mode 6, you'll erase what you've already done. The problem is, how do you set up a second matrix without going to mode 6? Because that's how we've always set up the matrix. Well, this is where it gets weird, okay? You still got to go to shift 4. So go to shift 4. And the weirdest part of this is, like, you would think you'd go to number 4 and set up matrix B, but that's not what you do. You actually go to 1. It says dimension. And what it means is you need to set the dimensions of a new matrix and then give the matrix. So long story short, mode 6, put in matrix A. Shift 4, dimension, number 1. Shift 4, 1. And it says, hey, what matrix do you want to dimension here? What matrix do you want to give dimensions to? And I'm going to say B, the second matrix. And now we're following a similar process. So it's again a 2 by 2, 5. So 5, 6, 7, and 8. It's saved. Well, it's not saved, but I've entered 5, 6, 7, 8. We can see them all there. Make sure it's all there before you move on, or else it'll mess up everything. Save it with AC once again. And now, in order to multiply them, shift 4. So shift 4, call on your first matrix, matrix A, that's 3. You can see matrix A, multiplied by shift 4, matrix B, which is number 4. You can see clearly that it's trying to do matrix A times matrix B. And if I press enter now, I should definitely get this answer I found before. So let's see if it does. 19, 22, 50, and 43, okay? So for a 2 by 2, it's actually, again, probably faster to do it by hand. But this is a good way to check your work if you have the time. And for sure with a 3 by 3 or a 4 by 4, this is the better way to do it. Okay, is that clear? If it's not clear, either watch the video again, or there's probably 500 videos out there teaching you how to make a matrix in your calculator with a Casio. So just watch those. It's all good. We all have to learn it our own way. Okay, let's do this. We want to multiply the matrices. I'm just going to start where I think I should start, which is check and see if it can be done in the first place. Maybe this is a trick question. So 3 by 2, this is a, what, 2x4, which I think Muhammad maybe said earlier. I kind of blew him off. 3x2, 2x4, yeah. And these are the same, so it can be done. And our final answer will be 3x4. So we know that in the end here, we're going to have a 3x4. So that's 3 rows. Again, you don't need to write that out. In fact, you probably shouldn't write it out. I'm writing it so that it's clear to you. We're going to have a matrix which actually has 16 elements, or sorry, 12 elements, as it's a 3x4. And let's start filling this in. This is the hard part, in my opinion. First row multiplied by the first column. I mean, assuming that we want this first. I mean, first row, first column, we need to multiply the first one, first row and first column. So I'm going to do that. Let's see. I'll write it out just so that we're clear. It's 2 times -1 plus 1 times 3. So this might take a little while. 2 times -1 and 1 times 3. So just to make life easier, I'll call it -2 plus 3 is really what I have. Do you know where I got those numbers? If you don't, there's no point in me going any further. Are we okay with the -2 and the 3? Maybe I should actually, I'm going back and forth because I don't trust myself sometimes. I'll write it out fully. 2 times -1 plus 1 times 3. And I'll even color code it. First one comes from the row. Second one comes from the column. All right, the rest is done the exact same way. All we need to do is just move this around, you know, first row, second column. So that'll be a 12 plus 0. First row, third column. That'll be a 10 plus a 1. Once again, I'm doing 2 times 5 and 1 times 1. So that's 2 times 5 is 10 plus 1. Let's keep going. I need to do the first row times the fourth column. That would be a -4 minus 4. And now I need to move to my rows. You can do them in any order you want. But yeah, this is how I do this. So once again, I want the second row and the first column. So I just look at the second row of my first matrix and look at the first column of my second matrix, sorry. Second row of my first matrix, first row of my second matrix. Did I say that right? And fill it in. Sometimes at this time of the day, my brain doesn't work the way I want it to. And I'll keep going through this process. Second row, second column. Second row, third column. Second row, fourth column. Third row, fourth column, why not? Let's go backwards. -2 and -8. 5 and 2. 6 and 0. -1 and 6. Clear? Clear. Isn't it nice that, you know, when you have a surface or something like this, I can make the surface. Isn't it nice that you can just move the colors around? I can't do that on a regular whiteboard. So that makes me happy that I can play with that stuff. On a regular whiteboard, it's not so nice. So this is not the end. This is just the beginning. Actually, we're almost done. We just need to finish these calculations. So -2 plus 3 is what, a 1? I'll just write them out as quickly as I can. 12, -18, 6, 11, -15, 7, -8, 6, -10. This is how we do it. Isn't that? I can't remember the beat, but do you know that song? 1990s classic, I'm just saying. Let's see. Yeah, okay, this one's done. Do we need to do any more? I can do the next one. Abdelgader says no. Hamza says no. Mohammed says no. Zada says no. Okay, well, the rest, you know, if you want more practice, you can do this for homework. The full solutions will be online. I will be putting them up, as I always do. How many different points left? Really one big one, but we've done kind of the most tricky stuff so far. Maybe two more points. Not too much left, and that's it for really the whole course. It's just practicing using those ideas. So the next topic, again, it's talking about this identity matrix. I'm not even going to count this as its own point. It's just kind of a neat thing or interesting thing about matrices. If you have a matrix that looks like this, you have the identity matrix. It means you have ones all along. I'm sorry, Ali. So just make sure you watch it. Maybe just, yeah, I wish there was something I could do to help, but if your internet's really bad, I can't really help. I'm sorry. Hamza, yeah, tomorrow's revision. So tomorrow what I'm going to do is I will do some practice for unit 6 and 7. Like I said, I'll do that worksheet, which will help you get full marks on those multiple choice if you come. And the rest will be review. I don't really have anything planned. So maybe I'll go through some practice problems and stuff. But yeah, tomorrow's revision. We can do whatever you ask. Whatever students want to do is probably what I'll do, because I don't have much planned. Okay, so let's keep going. So my point here was that when we have the identity matrix, it's kind of like multiplying by 1. So I'll say the identity matrix acts like a 1. And by that I mean, you know, think of 5 times 1 gives back 5, right? We put something in, we multiply it by 1, we get back 5. For matrices, it works the same way. We have A, we multiply it by I, we get back A. Okay, so let me just, I'll just show you one part of this example. If our identity matrix is 1, 0, 0, 1, and notice the reason I know that this is the identity is because it has 1s on the diagonal. I'll just show you what's A times I. And I just want to prove to you that it just gives back itself. And it's just a neat little thing that we kind of need to cover because it might come up. A times I would be 7, 3, 1, and 2 is in the first matrix A. The identity matrix is 1, 0, 0, 1. These can be multiplied because 2 by 2, 2 by 2, it's going to give a 2 by 2. We'll just do the same thing as we normally do, right? So we want 7 times 1 plus 1 times 0. So 7. We'll do the next one over, the top right part. It'll be 7 times 0 plus 1 times 1. We'll have 3 times 1 plus 2 times 0. We'll have 2 times 0 plus 2 times 1. I'm just doing the regular, same process as I did before. Okay, so Mohammed, you said you're confused. Let me rewind here. I got a bit distracted partway through by Hamza's questioning, but I'll try to rewind. It says we want AI if A is this. And I is the identity matrix. It's just a matrix that we put 1s in, okay? So our identity matrices, a 2 by 2 would look like this, a 3 by 3 would look like this, and so on. All we're doing is multiplying them. So this is our matrix A multiplied by our matrix I, and I'm doing the same process as I did earlier. So a 7 times a 1 is a 7 times 1. A 1 times a 0 is a 1, 0. Same as before. The point is, when you do this, what you end up getting is a 7, a 3, a 1, and a 2, which is still A. Like our matrix A is what we started with, and it's what we get. So even if we multiply it by the identity matrix, it gives back itself. I just wanted to make a note on that because I just wanted to show you that if you have an identity matrix, you multiply it by a matrix, it doesn't change anything. And that might seem silly, but it's just like saying, well, it's silly that when you multiply something by 1, you get the same number, but it does have, my cat is not happy right now. She's deaf, so she can't hear herself meow. And so sometimes she gets lost and she's like, help me, help me. And she'll be like standing right next to her. She'll be like, yeah. Calm down, cat. Calm down. I think she's just saying hi in a gentle voice, but it's like when people have headphones on, they can't hear. Like, hey, how you doing? Well, you probably didn't need to yell at me. Maybe you should turn the music down. Anyway, sorry. Let's get back to the math. I'm I'm very easily distracted today. Okay, you don't need to worry about identity matrix very much. The next topic, which is important, but the notes make it unclear, is the inverse of a matrix. So you might have been thinking about this. I'll try to take it slowly and clearly. It says, we know how to multiply matrices, but you might be wondering, how do we divide matrices? And it says, the short answer is we don't. The way we remove a matrix with an equation, so the way we divide something out is to use an inverse. And let me show you what that means. For example, it says here, we want to solve for matrix B in the equation A, B, C. So let me show you something. Just forget what it says on the rest of the page. I'm going to try and make it clear to you. What if you had this equation and you're trying to solve for B? Well, normally what you would want to do, you'd probably think that you need to divide both sides by A. And that would cancel out A and leave B equals C over A or 1 over AC. That actually is not allowed with matrices because we can't divide matrices. The equivalent to this 1 over A is called the inverse. So I want to show you how it works. It works kind of like how tan and stuff works. Just follow me here on the left side. If you want to move A to the other side, remember we're solving for B. You want B on its own. What you need to do is multiply both sides by the inverse of A. That will cancel A and bring it to the other side. Okay, and the final answer here is that we have the inverse of A times C. Matrices don't have division, but they have inverses. And so this is the big idea. It's just like when you have sine and cosine. I won't keep this here, but it shouldn't be a surprise that this is, what if this was the case? Well, you'd have, this is inverse sine of 5. It's the same thing. You have A times B equals C. Well, keep the B where it is, and you have A inverse equals C. It's kind of the same idea. All right, I just wanted to make sure that that was covered. I want to skip right to the example so you can see what's going on here. I'm going to skip this because I don't think we need to cover it. I'm just trying to get to the very bare bones, and the bare bones is the inverse. Okay, sorry, I'm going a bit quick, but the concepts will be simple. You'll see it. I'm trying to skip through the math text. It's too complicated sounding. So, to get the inverse of a given matrix, interchange the elements on the principal diagonal. I don't know why this says determinant. It says inverse. It should be inverse. Interchange the elements on the principal diagonal. I'll show you what it means in a second. Change the sign of the elements that are off diagonal. I'll show you what that means in a second. And divide every element by the determinant. So in other words, divide by the determinant of the original matrix. These are your steps for getting the matrix, the inverse. Let me show you what it means. It's not as bad as it sounds. So find the inverse of A. What we're going to do is we're going to interchange the elements on the main diagonal, which is this. I'll show you. The inverse is, you write the matrix again. It says interchange the elements. So you switch places. Are you with me so far? I just went change places. That's the first step, interchange the elements on the main diagonal. Second step, change the sign of the elements that are on the off diagonal. So look at these elements here and change their sign. So we have -4 and we have +3. Okay, I've changed their sign. So yeah, Mohammed, you got it. And now it says divide each element by the determinant of the original. So I need to divide everything by the determinant of A. All right, do you remember how to get the determinant? Let's just do this up here. The determinant of A is going to be 2 times -7 minus -3 times 4. That was that easy thing we did first that no one had any trouble with. So you still don't have trouble with it now, I'm sure. If you multiply those out, you'll have a -2. So long story short, what we're trying to do here is we have to divide by the determinant, that's this piece. So we have 1 over -2. And that'll be, we'll divide out every single element of this matrix. So divide every element by -2. So we have 7 divided by -7 divided by -2 is 7 over 2. 3 divided by -2 is -3 over 2. -4 divided by -2 is 2. And 2 divided by -2 is -1. I know that the steps are kind of just random. It seems like it's coming out of nowhere, but this is just how you find the inverse of a matrix. Thankfully, I'm going to show you how to do it on the calculator. So I know some of you don't have the calculator right now, so you can do it by hand. It probably takes just as long to do it on the calculator, but I want to give you two options, by hand and by calculator. All right, so Zara, sorry, you'll have to do it by hand. The rest of you that want to do it on a calculator, you can. And we're just following 3 steps when we do it by hand. Let's do it on the calculator. So once again, mode 6, A, it's a 2 by 2, that's number 5, 2, -3, 4, -7. So I've rewritten my matrix. Always check to make sure. With this equation, I'm going to solve cancer. Solve cancer. We'll solve COVID first, please. Might be better. We might not have to worry about cancer if we don't get rid of this COVID. Okay. Believe it or not, matrices are a fundamental part of linear algebra. In linear algebra, the systems behind linear algebra are quite literally what runs Google. So if you've ever Googled using a search engine, it's a giant computer matrix, which is constantly calculating. It spits things out. The most efficient way to gather data and to represent data, which you wouldn't know here, but it is the very first building block to building the most complex systems that we have in computers, besides quantum computing. So just a little note. Anyway, this is my matrix. Save it with AC. And now what am I going to do? What do you think I'm going to do next? If I want to do matrix stuff, well, I need the inverse, which, if we look here, has a little -1. So I can see a little -1 on my calculator. I'm probably going to use that. So Shift 4, call your matrix, and then go to this little button here, which is the inverse. Don't hit the exponent button. Don't hit -1. Don't hit any of that. Hit the inverse. Press enter. You'll see that this nice little, I can zoom. I can zoom? How did I even get that menu? Come back! Oh, it won't let me. Sorry, I'm so easily distracted today. Is this the same? 3.5, also known as 7 over 2. Yes, it is. Look at the next one, -1.5. That's -3 over 2. Same. -1 and -2. Or sorry, +2. They're all the same. All good? How do you feel about that? We only have, I think, one final question left. Yeah, one question style left. which looks complicated, but I can pretty much guarantee you're not going to have trouble with it. Okay. So what I'm going to do, don't worry about this. I mean, you can, if you have a TI-84, like Hamza, if you're using your TI-84, these are the steps. Just follow it. It's honestly quite simple. What I'd recommend is just bring up a YouTube video, follow it. You'll get it. It's just as easy as the Casio, maybe easier. And it saves all your data in the background. This is a 3x3. If you'd like more practice, you can try it out. Okay. I'll give you the answer so you can compare if you want to try it. We won't try it now, but just so you have something to look at, you don't need to go looking for the full solutions. This is the answer. And you'd get it directly from your calculator. This stuff is basically algorithms which are made for computers. 100%, Ibrahim, the basis of computer programming in a lot of cases, if you're solving things, is this. You start with matrices, you program the computer to take it, and then it does the work for you. But you can't program a computer unless you know how the matrices work. It's just the way it works. I've done a lot of programming to do with this. And if you don't understand matrices, you can't do it. It's like if you're trying to make computer animation, but you don't know how to make a computer model. Where do you start? So Zada, you're saying it's confusing. I don't disagree, but we're almost done. And hopefully it'll become clear when you look back at it. We can do one more inverse. If you're finding it confusing, let's do the inverse. We'll do one more practice because I don't want you feeling like you're left behind here because you don't have the calculator. I'll do one more with you or with everyone, and we'll see that it's not so bad. So the 3 steps are to switch places on the diagonal. Okay, I'll do it step by step. So our inverse, we'll just call this A, okay? So the inverse of A, what we're going to do, first of all, we write it out. We switch those places. We get -1 and 4, okay? I've switched the places. That's part of our recipe. Our second step is to change sign of the other numbers. And by other numbers, I mean the numbers that we didn't touch yet. So that's a -2 now, and this is a +6, okay? Positive, negative. We've changed the signs of the other numbers. And the third step is to divide everything by the determinant of A. So I don't know if these colors are helping or not, but hopefully it's at least somewhat clear. I changed the places on the diagonal. I changed the signs of everything else, and I'm going to divide by the determinant. I haven't gotten the determinant yet. So because I'm not going to do 2, I'll just write it, I'll write it down here. What's the determinant of A? You got to do this cross thing, okay? It's -1 times 4 minus 6 times -2. That gives us -4 plus 12, which is 8. So we're going to divide everything by 8. Let me double check because Muhammad is saying -1. Okay. I'm not sure how you got it, but I think it's 8, yeah? So our determinant is 8. So we take every number here, and we're going to divide it by 8. So really, every number, -2, 6, and 4, we take every number divided by 8, and that's our answer. So -1 divided by 8, -1 divided by 8 is -1/8. 6 divided by 8 is 3/4. I don't know why I used a calculator. I'm very embarrassed. 2/8 is 1/4. And 4/8 is 1/2. And that's our final answer. So switch the diagonal, change the sign of everything else, and divide everything by the determinant. That's how you get the inverse. Is that a little tiny bit more clear than it was before I did that example? I'm mostly talking to Zara. No offense, Ibrahim. I was talking about Zara. You get the determinant of A. I meant to write this. So let me be clear. The determinant of the original thing, because again, you think of it this way. Sorry, Abdelgader, you can't get the determinant of the inverse because you need the determinant to get the inverse. So how could you possibly have the determinant of the inverse before you have the inverse? It doesn't make sense. Because I did it. I'm not gonna, okay, so two things for Abdelgader. You get the determinant of the first one. We don't have the inverse yet. Notice this is not the inverse, okay? This thing here is not the inverse. That's just a step on the way to getting the inverse. This is the inverse, and we can't get the determinant of that until we don't get the determinant of that, okay? We get the determinant of A, which is the original matrix. As for Zara's question, it's clear for 2 by 2, but the big ones, we will never do the inverse of a large matrix because it's way too much work. It's an amazing amount of work. If you needed to do a 3 by 3, you would use a calculator, okay? But I'm telling you, I'm not going to give you a 3 by 3 on a test because that's just not the question I'm going to ask. So if you can do 2 by 2 stuff, you're okay. All right? All good? Yeah. Okay. Just for you. Just for you. Let's keep going. We've got one more topic. This topic looks complicated, and students who have solved equations in the past using, it says using Cramer's rule. It says it involves a calculation of at least 3 determinants, blah, 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 blah. We're not doing Cramer's rule. In fact, we kind of get to cheat now because we're at a higher level of math, and we can just jump straight to a really simple equation process. Normally, you know, if you had to solve for X, Y, and Z, if you were looking for these, you would have to have 3 equations, 3 unknowns, you know, all that stuff. With matrices, it's so fast. This will make Zara really upset because you have to use a calculator, but the basics are important, okay? And I still have to cover it because it is crucial. And the equation that we're going to use is this. We're going to try and solve for X, and we're going to use this equation. Okay, just remember that this is the equation we're going to use. The rest of it is just extra. You can read it, but I'm not going to go into why it works because it's not important for what we need to do. Yeah, Muhammad, you would have done something similar in math in 1700. Maybe at the end, I think you probably did this. So if you're having deja vu, that's why. And yeah, Zara, remember, you can download the calculator. I think on the iPhone, if you have it, is Calc ES. On the Android, if you search something called Calc Colorful is the one that I use, you can get the same calculator. All right, let me show you how this works. I'll try to make it as clear as you can. It says solve the system of equations. You'll be okay. Let's not mess it up today, Ali. You have 3 pieces. This set here, this system, the system just means more than one equation, has 3 parts. The first part is made of what's called coefficients. So we can make 3 matrices. The matrix A is what we're going to call the coefficient matrix. You don't even need to know the name, you just need to know what it is. So the matrix A is going to be made up of that. And so I'm going to draw this here. Matrix A is 2, 5, -1, and -3. Those are my blue values here. All my coefficients go in my coefficient matrix. The variables, also known as the unknowns, so I'll just say my variable matrix, which are our, it's going to be a column matrix when we write it, are going to be made of all of our variables. So in this case, I only have x and y. So even though it looks like x, x, y, y, you have to make it a column. So what I mean is just put them vertically like this, x and y. Our matrix X, big X, is made up of all of our variables, in this case, x and y. Okay, so you just steal your variables from the question. Finally, we have what's called the, well, I call it the answers matrix. I can't even remember what the real name is, but it's our answers, or our constants, also a column. It's really, it should be called our constants, but it's okay. You again steal that. So let me make sure this is color coded. 7 and 8. So the matrix C is 7 and 8. Okay, you have 3 pieces. Once you know what they are, the calculator does everything for you. Okay, and I'll show you what that means in a second. 18. Why are you both yelling at me? 18. 18, yes. What are you talking about? I knew it was 18. I was just testing you just to see if you're still awake. Sorry. We have 3 pieces. We get A from the coefficients, X from the variables, C from what's on the right side. And this is how we solve this. From the earlier page, X, our equations, or sorry, our variables, are what we're being asked for, is the inverse of A multiplied by C. Or in other words, our X and Y is 2, 5, -1, and 3. Get the inverse of that and multiply it by your C. And I know this looks complicated, but it's just following this formula. This is our matrix X. This is our matrix A inverse. This is our matrix C. Hansa. You're wild, bud. You're wild. Okay, now what we need to do is solve this by calculator because, well, we could do it by hand, but I'm saying that this particular section you might want to use the calculator for. You could do it by hand, but it would take a lot longer. So I'm going to show you how to do it on the calculator. Sorry, Zara, but you should download it. You can probably download it now while I'm talking. Mode 6. Set up the matrix. It's a 2 by 2, so number 5. It's going to be 2, -1, 5, and 3. The matrix is okay. I'm going to save it with AC. Once again, you never press mode 6 again for the same problem. You need to go to shift 4. So I'm going to go to shift 4. Remember the weird trick? I need to go to dimension and then put in my new matrix. This is called C. I'm going to call it C. So matrix C, that's number 3. It's a 2 by 1. That's 6. Now it's a column. C is 7 and 18. I'll save that with AC. What do I need to do? The inverse and multiply. It's okay. Zara, you're not wrong, but we will have similar questions that relate to the ideas. But if you want to just coast, that's okay too. Go to shift 4, matrix, 3, get the inverse, multiply it by matrix C, which is number 5. So just check your work. Matrix A inverse multiplied by matrix C. Boom. Wait a second. That doesn't look right. So what I'm going to do is check my matrices and make sure that I put in the right numbers. 2, -1, 5, and 3. Okay. 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 I'm going to double check my matrix C. 7 and 18. I think maybe I forgot to do an inverse. feel like I put something in wrong. This should give a 3 and a -1. But I'm a little bit confused as to what I've done wrong. So maybe I'll have to ask Hamza. Hamza, you get this question? Because I'm wondering what I typed in wrong. I can't find the mistake for the life of me. Manual it is. You can do it manually. I'm just, oh, yeah, this is my silly mistake. Look, 2, 1, 5, -3. So you can see how as soon as you put in something wrong, the whole thing goes wrong. I need to put it back in. Yeah, it's wrong. So I'm going to dimension a new matrix, matrix A, a 2 by 2, 2, 1, -3. Isn't this exciting? And I just saw your question there, Ibrahim. I think it was Ibrahim. How to find the inverse button? Yeah. Put in 3, and then once you've got it, you put in power -1. It is not actually a power. It looks like a power -1. That's the inverse, and then C. Boom. 3 and -1. All right, we made it. We made it. I give it an 8.5. Okay, I'm going to keep going. This is the last topic. We've actually covered all the topics now. I'm just going to do a few more examples so that you can solidify it. So let's compare here. We know that x and y are equal to 3 and -1. So the final answer here, x equals 3, y equals -1. It didn't give me a lot of space to do this. Let's do another one. Example 2. We're going to solidify it, okay? And this one has enough space to do it. Once again, we have a coefficient matrix we need to make from the coefficients. 2, 1, 7, 1, -1, -2, -3, +2, and 3. So that'll be my A. My coefficients will be x, y, and z. And my answers, I guess, will be those. And to solve the question, the whole point is that it's asking what is x, y, and z. And our formula is x, the unknowns are A inverse times C. So I'll write it like this. X, y, and z, that is our matrix X, equals the inverse of the coefficient matrix, which is 2, 1, 7, 1, -1, -2, -3, 2, and 3. That's our A inverse. And then C is I'll call it the answers, right? I'll color code it so that you can look back on this and make some sense of where these things are coming from. But this is all calculator now. This will give us our answer. Can you leave after you finish this example? Yeah, we can, because I'm actually going to finish then after this example. Everything else will be just extra, okay? We'll do our review tomorrow. So let's finish this one. You just tell me, do you want to see it how I put in the calculator, or do you want me just to give you the final answer and we'll leave it at that? You tell me. Ali wants the calculator, Mohammed wants the final answer. I'll do both, okay? For Mohammed, because I know you've probably got to go somewhere, I'm going to give the final answer because I've done this before. The calculator should give this, which means x is 3, y is -5, and z is 2. That's my final answer here. So if you want to go Mohammed, you can. I'm just going to show how I would do this on the calculator one more time, because it's a little tricky. When I first learned this, I got really lost on which buttons to press at which time. But once you have the first step done, that's most of it. So I should get a 3, a -5, and a 2. So let's start from the beginning. Mode 6, set up my matrix, 3 by 3. This is useful if you're using an actual calculator. I've kind of got to go slow, and I don't even have my mouse here, so it's slower. All right, I'm going to double check this time. That was my downfall last time. My mouse is freaking out. Wow, what is happening? Sorry, 1 second. Okay, I'm going to check. 2, 1, -3, 1, -1, 2, 2, 7, -2, and 3. Okay, so I've got the right matrix. I need to dimension a new matrix, which means make a new one. Go to matrices. Oh man, I forgot to save. Okay, save. Shift 4. I'm going to dimension a new matrix. Go to 1. I'll go to 3 because I like it to be called C. This is a 3 by 1. Put in a -5, a 12, and a 37. That's my C. I'm going to save that. Finally, I need to do the inverse of A multiplied by C. And you'll notice with matrices, you don't actually need to put the multiplication sign, although it is probably safer to do that because sometimes it goes weird. So I'll put the multiply in the middle, and I should get 3, -5, and 2. So Ibrahim, good job. I think Hamza, maybe you did that already. Maybe you got the same, I'm not sure. But this would be our final answer here, and this is why. All right. Okay, good. I'm glad, Ali, it makes sense now. This is the big idea. The most important part of this question is taking the coefficients, putting it in, making an A, getting the inverse, and so on, and it just all matches up. So I'm glad it makes sense. What I'll say is that maybe on the final, even though you don't need to set it up as the matrix, in the final, even though you don't need to use your calculator to solve it, maybe a question will be, given this system, what's the coefficient matrix? Or maybe they'll say, what is the answers matrix? What's C? Maybe. Just some ideas, okay? I'll make it pretty clear what you're going to expect tomorrow in the review class. But for now, this is all we need to know. So I'm actually going to stop the recording here. And I'll stop the recording here. So bye-bye, everybody. See you in the next recording.